Okay, so in the last lessons, we already finished studying about the Ricardian model. Do you still remember it? So in Ricardian model, we consider two countries. Follow my example last time that two countries we consider are home and foreign country, and we consider they produce two goods, the cheese and wine, and we only consider one factor economy that one factor of production is labor. And today is an extension of the last lesson, so it's quite easy and quite similar to the last lesson. So maybe we just take a quick look. And this week we also consider two countries, two products, but we consider two factor economy. So we assume that two factors of production are labor and also capital. So why capital? Let me give you this example. The Canada exports the forest products to the US, not because its lumberjacks are more productive relative to the US. However, because Canada has more forested land per capita than the US, that's why Canada export the forest product to US. So capital is also very important factor that help the country gain the comparative advantage. And that is the Hextred all-in model is what we will learn today. So today we will go through the two-factor economy with the Hextred all-in model. And for more detailed information, you can read the chapter 5 of the book Berkman, International Economics, Theory and Policy. I already gave you in the syllabus. Okay, so after this lesson, I expect that you guys can explain how different it is in resources, generate a specific pattern of trade, and you understand the Hextra all-in model and also know how to construct the PPF. Do you still remember what is PPF? PPF stands for the Production Possibility Frontier. Okay. So this week we will change our two products. It's not cheese and wine anymore. We will consider the cloth, and the unit is meters, and food. The unit is calories. And we consider two factors of production, that is labor and capital. And we also can consider two countries, home and foreign. But uh, the example today I give you, maybe we just consider one country, then you can just extend it to two countries. And the difference is we assume that the immobile factors that were specific to each sector. For example, we need the capital in cloth and land in food are now mobile in the long run. It means it means that the land we use for farming can be used to build a textile plant. Or conversely, the capital we use to pay for a power loom can be used to pay for a tractor. So the factors can change, can run exchange with each other. So in the long run, both the capital and the labor can move across sectors. Okay, so let's see. We assume that both cloth and food are produced using the capital and labor. and the amount of each good produced given how much capital and labor are employed in each sector. Okay, and I will use the notation that is QC and QF. So I have QC is equal to the amount of the cloth produced given of the capital used to produce cloth and the labor to used to produce cloth. We have QC and QF is the output labor of cloth. KC and KF is the amounts of capital employed in cloth production and food production. And LC and LF is the amount of labor employed in food production and cloth production. Sorry, this one should be cloth and this one should be food. Okay, remember F is for food and C is for cloth. And K and L is fixed supply and capital. Fixed supply of capital and labor in the economy. And I have AKC is the capital used to produce 1 meter of cloth. ALC is the labor used to produce 1 meter of cloth. And AKF is the capital used to produce 1 calorie of food. And ALF is the labor used to produce 1 calorie of food. What is different from this one and the ALC we have in Ricardian model? ALC in Ricardian model is the unit labor requirement to produce 1 pound of cheese, right? So it's required. But here is the labor we used. So here we can control the uh, resource, the capital and labor we want to produce the products. It's not the required, but we can choose. Okay. Okay, let's look at this example. We have the capital used to produce 1 meter of cloth is 2, and the labor used to produce 1 meter of cloth is also 2. So to produce the quantity QC of cloth, we need the total resource is equal to AKC times QC plus ALC times QC. And AKC here is 2, so it's equivalent to 2 QC working hours plus 2 QC machine hours. Okay, and the same AKF is the capital used to produce 1 calorie of food and is equal to 3, and the labor used to produce 1 calorie of food is equal to 1 uh, working hours, 1 works hour. So to produce QF food, the total resource we need is equal to AKF times QF plus ALF times QF, and is equal to 3 QF work hours plus 1 QF machine hours. And we have earlier we say that we assume K and L is the fixed supply of capital and labor in economy. So when we produce QC, and QF, we have to make sure that the total capital will not exceed the limitation, the capital capacity or the labor capacity. So that's why we have the constraint that the total resource we need to produce uh, meter QC meters of cloth is less than or equal to the capital capacity, and the total resource used to produce QC uh, meters of cloth and QF calorie of food is less than the labor, less than or equal to the labor capacity. So we just replace the number here. We will have 2 QC plus 3 QF will less than or equal to 3000, and 2 QC plus QF is less than or equal to 2000. And in this case, okay, because we assume that the capital capacity is 3000 and the label capacity is 2000. That's why we have this number. And here we assume that there is no possibility of substituting labor for capital, or no substituting from capital to labor. And based on the constraint, we will construct the PPF line. So the same as last lessons, that we just make the less than or equal will become equal. So we have the limitation. So we will find if they specialize in food, if they specialize in food, then the maximum calorie of food they can produce, that is, this one will equal to 0 if they specialize in food, right? So the maximum it will be equal to 1000. And if they specialize in cloth, the maximum quantity they can produce is 3000 divided by 2, so 1500. So we have 2 points, that is QF is 1000 and QC is 1500. So we can draw this line. This line is the capital constraint. So the second line we consider the labor constraint. So for labor constraint, if we use all the labor to produce food, the maximum calorie of food we can produce is 2000. And if we use all the labor to focus on producing cloth, the maximum cloth we can produce, that is 1000 meter, 2000 divided by 2. So we have QC is equal to 1000 and QF is equal to 2000. So here we can draw the second line that is about the labor constraint. Okay. So the first one, we when we consider about the capital constraint, we just assume what happened, what is the maximum amount they can produce food if they focus all the capital on producing food, and how if they focus all their capital on producing cloth. what is the maximum quantity they can produce for each products. So we can draw the line. So after we draw two line for the capital constraint and the labor constraint, we see the point 3 is the intersection between the labor constraint line and capital constraint line. And we can see here the yellow line, the orange line, this one is the PPF of this country about producing uh, food and clothes. And how we can calculate this one? This one is when it's the intersection between them, so we use Q2QC plus 3QF and equal to 2QC plus QF. So you can calculate that the QC is equal to 750 and the QF is equal to 500. And as we can see here, the labor constraint slope is equal to -2. So it's equal to 2000 divided by 1000, the -1. And if we take the absolute of the slope, we will have is equal to 2. Okay, and the same we can calculate the capital constraint slope is equal to 1000 divided by 1500, and we have the value -2/3. And do you still remember in the Ricardian model we say that the slope, the opportunity cost of G's in terms of y is the absolute value of the slope, and here is the same. However, the opportunity cost of cloth in terms of food here is not fixed, it change. So we can see the red light here is the PPF, and the opportunity cost of cloth here to food is not a constant because we can see the light is crinkled here. And for the point that in this area, located in this area in the left side of the point 3, the opportunity cost of cloth is 2/3. Okay, and for the when the economy are produce mostly cloth is all the point in this area, in the right side of the point 3, the opportunity cost of cloth is 2. So we can see that the opportunity cost of cloth is higher when more unit of cloth are being produced. Okay? Here I already take note here, the opportunity cost of the cloth will increase when they focus more on producing cloth. Do you have if you have any question here, just feel free to ask me. And to make it closer to reality, we allow the possibility of substituting label for capital. So like what it mean that we can choose either we want to use more labor or we want to use more capital. So the Kinkat light in this the Kinkat light ppf here will become a bulb shape like this because there is the substitution between label and capital. The shape the light shape the light shape is changed. However, the opportunity we still can see that the opportunity cost of the cloth will increase when they focus more on producing cloth. And where on the ppf the economy will produce the products, it depends on the price, and they will find the point that maximize the value of production. And the value of production is measured by the price of cloth times the quantity of cloth plus the price of food times the quantity of food. So this is like the revenue. So we have our isovalue lines like this, and we can see that here this point is the point that have them gain the maximum the highest value for the economy's production. And at that point the slope of ppf is equal to negative relative price of cloth to food. So here the opportunity cost of cloth will equal to the relative price of cloth to food. Okay, so economy will tend to produce uh, at the point that the opportunity cost of cloth to food is equal to the relative price of our cloth to food. And because in two model factor we have room for choices in use of input, so either we can choose to use more labor or capital. For example, you are a farmer, you can choose if you want to use more labor force or you want to use more machine. It depends on you. So the graph here represent the possibility of input combination that produce 1 calorie of food. So the x-axis is the label input per calorie, and the y-axis is the capital input per calorie. So we will see the blue line is the relationship, the combination between the label input and the capital input. So as we know, if let's call W is the wage rate, like the money we have to pay for the label, and R is the rental cost for the capital, like for example the rental cost for the machine. So the input choice will depend on the ratio of the wage rate and the rental cost. This is easy to explain, right? For example, between label and machine. So if the wage rate is high, we will tend to use more machine and reduce the quantity of labor. When we produce 1 calorie of food, for example, we need 3 label and 1 machine to produce 1 calorie of food. However, the wage rate is quite high, so we change to maybe we use 2 label and 2 machine. Okay, or if the rental cost is increased, we will tend to use more labor costs and reduce the amount of the machine. So it's represent this slide. And here we can calculate how to calculate the price of cloth one and the price of the food. So we have the notation PC and PF represent for the price of cloth and food. We can see that the price of cloth will equal to the wage rate times the labor used to produce 1 meter of cloth, plus the rental cost times uh, the capital used to produce 1 meter of cloth. For example, I use 2 hour to produce 1 meter of cloth. We need 2 hour to work hour, and we need 2 machine hour, and we have to pay for example $5 for the label, and we have to pay $7 for the machine. So the price of cloth, 1 meter of cloth will equal to 2 times 5 plus 2 times 7. So we have the price will equal to $24, right? So the same you can calculate the price for the food. Look at this figure. It represents to us the relationship between the relative factor price and the relative factor demand. So we can see the x-axis is the relative demand for labor to capital, and the y-axis is the relative price for labor to capital. So we can see the relative factor price will determine the relative employment levels in both sectors. So as I told you earlier, the example earlier, if the wage rate increase, it means the relative price to relative price of labor to the capital increase. They will tend to use more capital and less labor. So the relative demand of labor to capital decrease. And we can see here the RDC is the demand curve for cloth, for the labor, okay, for the labor in cloth production, and the RDF is the demand curve in food production. It show uh, the labor capital ratio. So we can see at any given point of the relative factor price, uh, the relative price of labor to capital. We can see the relative here is the relative demand for labor to capital in food production, and the same relative price of labor to capital. We can see another point here, that is the relative demand of labor to capital in cloth production, and we can have the conclusion that the production of cloth will always use more labor relative to the capital than the food production. And when it happens, we will say that the production of cloth is labor intensive and the production of food is capital intensive. So we notice that the definition of intensive depends on the ratio of labor to the capital used in production, not the ratio of labor or capital to output. Therefore, a good cannot be both labor and capital intensive. It only can be one, either labor intensive or capital intensive. They cannot be both. And since here we see the demand curve for label in the cloth production, and here is a demand curve in the food production, so we can aggregate them and we can have the aggregate demand curve like this, and we can conclude that the aggregate relative demand curve for factors is a weighted average of the relative demand for factors in each sector. So here we can see how we prove it in mathematical formula. So here we have the relative demand for labor to capital, so it's equal to okay, let me from here first we eliminate this and eliminate this, and with it will equal to LC divided by K plus LF divided by K. So we have LC plus LF and divided by K, and it's equal to L divided by K, right? So here we can see this is the relative demand for labor to capital is equal to this one is the relative demand for labor to capital in cloth producing sector, and here is the relative demand for labor to capital in food production sector, and Kc, the ratio between Kc and K, this one we can consider as a constant. So we can see that the aggregate relative demand for labor to capital is equal to uh, the weighted average of relative demand for labor to capital in cloth production sector and the relative demand for labor to capital in food production.